Hello students, this is Mr. Martin, and today we're going to talk about Chapter 7 in Geosystems, the weather. Now the weather is a short-term, day-to-day condition of the atmosphere. It's a snapshot of the atmospheric conditions. Climate is the long-term average over decades of weather conditions and extremes in a region. The elements that contribute to our weather are temperature, air pressure, relative humidity, wind speed and direction, and seasonal factors such as insolation and sun angle. Now, air masses, they are bodies of water of air with uniform temperature, humidity, and stability characteristics. They initially reflect the characteristics of their source region. As they migrate, they take on the characteristics of the new location. The classification of air masses are according to the moisture and temperature characteristics of their source. So moisture, M for maritime or wet, and C for continental or dry, and temperature, A for Arctic, P for polar, T for tropical, E for equatorial, and AA for Antarctic. So an MT is a maritime tropical air mass, a CP is a continental polar air mass. So rising air causes precipitation. So to form precipitation, air masses must be lift and rise in altitude to reach the dew point temperature, condense, and form clouds. There's 4 types of atmospheric lifting: convergent lifting, convectional lifting, orographic lifting, and frontal lifting, which are cold and warm fronts. So convergent lifting. Air flows towards the area of low pressure, from high pressure systems to low pressure systems. So the low pressure center is where air converges and ascends. So when a low pressure center comes across the continent, air flows into it, collides, goes upward, forms clouds. Convectional lifting is where the air above the warmer surface is heated and rises. Hot air always rises. So the warmer surfaces produce convectional lifting due to local heating. Orographic lifting occurs when air is forced to ascend upslope as it is pushed against a mountain. There's something called the rain shadow effect, where you have a large mountain range, and on the windward side, the air goes towards the range, air is forced up over the mountain, it cools to the dew point, releases its water. Then as it goes down, you'll always have a dry side of the mountain or a drier side of the mountain, depending on where it's located. On the leeward side is where you call the rain shadow effect, and there's actually places like in South America over the Andes Mountains, which is one of the driest areas in the world due to this rain shadow effect. Now, frontal lifting is what causes the weather in Dallas. A front is a transition zone between 2 air masses with different temperature, humidity, and density characteristics. A front Now the front is this transition zone between the 2 air masses. And since density differences are most often caused by temperature differences, fronts usually separate air masses. A front is a transition zone between 2 air masses of different densities. Since density differences are most often caused by temperature differences, fronts usually separate air masses with contrasting temperatures. The leading edge of a cold front air mass is a cold front. The leading edge of a warm air mass is a warm front. Frontal lifting. The front is a transition zone between 2 air masses of different densities. Since density differences are most often caused by temperature differences, fronts usually separate air masses with contrasting temperatures. The leading edge of a cold air mass is a cold front. The leading edge of a warm air mass is a warm front. So a cold front forces warm air aloft. Remember, the warm air always rises. So as a cold front comes through, it travels up to 40 kilometers per hour, and there's precipitation behind the cold front. The cold front comes through, it forces the warm air up, which creates clouds that reach the dew point, condense the water, and rains in the warm area above the cold front. A warm front is when the warm air is moving and it actually slides up and over the cold air. It can be 1,000 kilometers wide and travels a little slower at 16 to 24 miles per hour. The precipitation ahead of the warm front is caused by the warm air rising up and over the cool air mass. So weathermen try to forecast the weather and have several data sources. They use satellites, weather balloons, ground installations, Doppler radar, and forecasting technology. Doppler radar is radar that can show the precipitation in the thunderstorms. So as a squall line comes through, you can see the areas and bands of high precipitation. You can also see what's called a hook echo, which is a hook where tornadoes form. Now, violent weather is usually in the forms of ice storms and blizzards, thunderstorms, derechos, tornadoes, and tropical cyclones. Thunderstorms are powered by the latent heat of condensation, and they're associated with heavy precipitation, lightning, thunder, hail, strong winds, and tornadoes. Thunderstorms develop by rising air. All rain comes from rising air. You have updrafts and you have downdrafts at the colliding air masses. And these develop and always create, over time, these large anvil-like clouds. Now we can look at lightning strikes around the globe. This is a map of total annual lightning strikes from January 1998 to February 2012. You can see that the lightning shows the areas of the greatest amount of thunderstorm activity, like the rainforests in Africa, places in Central America and South America, and Florida. Now, derechos are lines of intense, widespread, and fast-moving windstorms and sometimes thunderstorms that moves across a great distance and characterized by damaging winds. These are associated, again, with usually a cold front coming through, with that line between the air masses and a large area of rising air. Now, tornadoes develop because stronger winds override weaker winds and create a rotation. And that rotation can lift in the updrafts and become a tornado out of a thunderstorm. Tornadoes are very prevalent in the central plains of the United States. Oklahoma actually has the largest amount of tornadoes in the entire world per square mile. Texas also has pretty high amounts of tornadoes. Tropical cyclones are rotating storm systems that originate over warm tropical waters. They're classified by wind speed and are powered by the latent heat of condensation off the warm ocean. In North America, we call them hurricanes. In China, Japan, and the Philippines, we call them typhoons, and we call them cyclones in Australia, India, and Indonesia. The warmer the ocean and the atmosphere, the more powerful the storm. Now, tropical cyclones are classified by a tropical disturbance, which is a variable low over warm water. Then you have a tropical depression when you have winds up to 38 miles per hour. A tropical storm, which is what becomes a named storm in North America, is when the winds reach 39 to 73 miles per hour. They're classified as a hurricane when the winds become more than 74 miles per hour. And in the West Pacific, they are classified as a super typhoon at 150 miles per hour or stronger winds. Now, the primary areas of the cyclone formation are across warm equatorial waters that are carried by the trade winds that eventually may make landfall. So your typhoons typically will follow this path. Your typhoons or your hurricanes will follow this path, and your cyclones follow this path. They're the exact same weather phenomenon, they just have different names depending on what part of the world they're in. This is a map of the worldwide cyclone tracks from 1856 to 2006. You can clearly see the pattern of the warm waters, where they originate, the directions that they flow, and the areas of landmass that are impacted. Our typical hurricanes here in the United States come off the coast of West Africa, travel across the ocean, build from that heating from the warm oceans, which is why they're always in late summer to early fall, and sometimes make landfall, and sometimes curve around as they hit contrasting air masses. The cyclone structure is a circular band of clouds that rotates around an eye. So if you look at it from this direction, you have the eye with rising air around it, very high pressure in the center of descending air, and the high altitude winds are what steers it like a top.